Welcome to qnawire.
Here we have an equation of motion, and some of the letters in here are Greek letters. So if you're not familiar with them, the one that looks kind of like a W is omega, and the one that looks kind of like a D is delta. And those are constants in this equation, and A is also a constant, so our variable is t. So to find the velocity, we start by finding the derivative of position. Velocity is a derivative of position. Okay, so we're going to leave our constant a, and then we notice that we have a composite function, so we're going to use the chain rule. The outer function is cosine, and its derivative is negative sine. So we have negative sine of omega t plus delta. Now we need to multiply that by the derivative of the inside, and the inside is omega t plus delta, and so its derivative would be omega. Okay, let's simplify this a little bit. What we could do is multiply the a, the negative, and the omega together, and we have the opposite of a, omega, times the sine of omega t plus delta. So that's part A. We have our velocity. Now for part B, we're interested in finding when the velocity is zero. Okay, that doesn't mean the time is zero. That means the velocity is zero, and we're solving for the time. So we're going to take our velocity, negative a times omega, sine of omega t plus delta, and we're going to set it equal to zero and solve this equation. So that's solving a trigonometric equation. It's going to involve lots of trig. The first thing we can do is divide both sides of the equation by negative a omega, and we have the sine of delta t plus, omega t plus delta equals 0. Okay, the next step is going to be to take the inverse sine of both sides. And so we have omega t plus delta equals inverse sine of 0. That means the angle whose sine is 0. And it just so happens, lucky us, that one of the angles whose sine is 0 is just 0 radians. But unlucky us, it also just so happens that there are infinitely many more answers. So let's take a look at that. So here we have our unit circle. We have 0 radians. This is the point 1, 0. So the sine is 0. So sine of 0 is 0. Okay. However, you could go around the circle again and get to the same spot, get to the same sine value, and you've gone 2 pi radians. Or you could go again and you've gone 4 pi radians, or again and again and again. You could go infinitely many times around the circle that way or back the other way. So you can add 2 pi radians infinitely many times. Similarly, you have another angle over here that has a sine value of 0, and you could come back to it infinitely many times by adding 2 pi radians to it. Now, let's consolidate those together. We have two answers at 0 and at pi, and how far apart are they? They are pi radians apart. So if you have one answer, you can go pi units and get to the next answer, go pi radians and get to the next answer, and so on, infinitely many times. So how do we express that? We can take one of our answers, 0, and say that we're adding pi times n, where n is an integer, So that means you can add pi 1 time, you can add pi 2 times, you can add pi 99 times, you can subtract pi 142 times. You get all of the possibilities. So we're going to incorporate that into our answer back here. We're going to say that omega t plus delta is not just 0, but 0 plus pi n, where n is an integer. Now, remember the goal is to solve for time, so we're going to isolate t from here. So we're going to subtract delta from both sides, and we have omega t equals negative delta plus pi n. We could write that as pi n minus delta, just to make it look a little bit better. And then finally, we'll divide both sides by omega. So we have t is equal to pi times n minus delta over omega. What a strange looking answer.